All right, we're gonna solve by taking the square root. So this means we're gonna simplify the part inside the radical, and if there's a fraction, we will not leave a square root in the denominator, the bottom. All right, I'm going to factor this. So 2, it's an even number, so I'm dividing by 2. 2 goes into 19 9 times, right? 9 times 2 is 18, so 6. $45 plus 3, 48. Divide by 2 again, 24. 2, 12, 2 times 6, and 2 times 3. So every pair can leave the square root as 1. So 2, 2, and 2. And 3 is left over. So 2 times 2 is 4, times 2 is 6. So 6 root 3. So you break this number up inside into its prime factors. Then you pull out the pair and they get multiplied. And whatever's left over, the single, like the lone number, those stay behind. So 6 root 3. Root 3, root 27. When we're multiplying square roots, we can multiply the argument, the part on the inside. So what's 3 times 27? 3 times 25 is 75. Plus 2, 4, 6, so 81. Square root of 81. That's a perfect square. That's 9. Too easy. 4 root 6. Okay. We're multiplying, again, square roots. So the idea here is you multiply the outside part times the outside part. It's understood there's a 1 in front. So 4 times 1, 4. Then inside part times inside part. So this is going to be root 36. 36 is a perfect square. So it's going to be 6. Another way to look at it, when you're multiplying square roots and the arguments match, the part inside matches, well then the product is just the part that's on the inside. So 6. So 4 times 6 would be 24. All right, number 6. Five root 24. 3 root 10. All right, what did I just say? Outside times outside. Inside times inside. Now, could we have simplified first? Yeah, we could have. I mean, it doesn't really make a difference. We're going to run into it anyway, so look, 24 and 10. Actually, 2, 120, 2, 60, 2 and 30, 2 and 15, 3 and 5. So here's a pair, here's a pair. So we're gonna get 15 times 2, right? Because they can leave, this pair will come out as a 2. This pair will come out as a 2. And this is left inside. 3 and a 5, which is 15. So 15 times 2 is 30, times 2, 60. Not bad. 5 over 16. All right. Moving right along. Okay, root 5 over 16. I like to break this up into, right, the property says you take a square root of a fraction. I can break it up into a square root over a square root. And this is nice because look, the denominator, we don't want to leave any fractions. So rationalize the denominator is what that's called. So square root of 16 is a perfect square. That's it. That is it. Okay. Number 8, 35 over 36. All right, I'm gonna, again, same property. Square root of the top, square root of the bottom. Perfect square on the bottom, 6. 35, can 35 be reduced? 7 times 5, both of those are prime numbers. So no, top can't be reduced. That's the answer. Root 35 over 6. 13 over 20. Number 9, root 13 over 28. Root 13, that's a prime number, so I can't reduce that anymore. Root 28. Root 28 is not a prime number. It's an even number. It's not a perfect square. So I can factor this into its prime number. So 14, 2 and 7. So root 13, 2, right, because the pair can leave, and then root 7. 7 is left over, so it's left in the radical. So now, we want to rationalize the denominator again. I don't want square roots in the bottom. So, I'm going to multiply the top and bottom by root 7. But I can multiply anything by 1 and not change the value. Right, so this is a clever one, right? I'm using root 7 over root 7. Why? Because there's a root 7 right here. All right, root 7 times root 7 is just 7, right? When two radicals are being multiplied, you keep the inside part if they're the same. 7 times 13. 21, carry the 2. So root 91. So 7 times 3 is 21. Carry the 2, 7, 8, 9. 91, root 91 over 14. Right. Feels like we're flying through these. These should be pretty quick. If I'm going too fast, just pause the video and see if you can work it out for yourself. But 7 over root 12, rationalizing the denominator. You want to simplify it first? We can simplify it first and see what happens. So 3 times 4. 4 is 2 times 2. So this comes out. What's left over? Root 3 over 7. So here, I decided to rationalize the denominator first, or factor first. We could have multiplied by root 12 over root 12, but you know, why deal with bigger numbers if I can deal with smaller numbers? Okay, I'm going to, again, get rid of the square root in the bottom by multiplying by root 3 over root 3. 2, root 3 times root 3 is just 3. 7, root 3. And then on the bottom, 2 times 3 is 6. All right, we're a third of the way through. How many are there? 30, exactly 30. I'm gonna work out 30. All right. 8 over root 3. Eight over root 3. This one's easy. We already know how to solve this. Root 3 times root 3 is just 3. 8 times root 3, 8 root 3. Okay, next one's going to be interesting. 12 over root 3. All right, 12 over root 3. Same thing. Probably should have just left it up. So root 3 times root 3, 3. 12 times root 3. Here, the 12 and the 3 can cancel because 12 is divisible by 3. 3 goes into 3 once. 3 goes into 12 4. 4 root 3. Final answer. Root 3. All right, gets a little bit more interesting. So 2 over 1 minus root 3. Now if I want to clear the bottom, right, I don't want a square root in the denominator. I can't just multiply by root 3. Because if I multiply by root 3, I'm going to have to distribute. So this is going to be 3, but then root 3 times 1 would be root 3, and I would still be left with a root 3 in the denominator. So root 3, just root 3 won't work. I'm going to have to use, it's called the conjugate, where you have a pair of binomials, one's addition and one's subtraction. So separated by a plus and a minus sign. Right? Where I multiply the bottom by, I'm going to multiply the top by as well. All right, so when I multiply the bottom, the whole reason why we're using conjugates is because there's a nice, beautiful property. If I FOIL this out, the middle terms are guaranteed to cancel. So that means, right, it's basically a difference of squares working backwards. So I'm going to do a squared minus b squared. But if you remember a difference of squares, remember a difference of squares, right? A difference of squares says that I can expand it like this. So that's exactly the case we're in. This is right there. So I can work backwards. If this is the case, then I can do a squared minus b squared. So a squared is going to be 1 squared, that's nice, minus b squared. So root 3 times root 3, which is just 3. That's nice. And then the top, two times that. So I don't distribute because, you know, it's simplifying, right? Like, what's simple? Simple is subjective in my opinion. So is it more simple to distribute, or I like to leave it out because on the off chance that you could simplify it, which in this case will happen, right? So if you tried to distribute right now, you have to factor it back out and then simplify. So 3 minus 1 is negative 2. Okay, there's a 2 on top and a 2 on bottom. So on the bottom, it's just 1, negative 1. Dividing by negative 1 is the same as just saying negative 1. So negative 1 plus root 3. Again, could you distribute? Either one of these are acceptable in my opinion. So, you know, what's more simple to you? I like leaving it right here, but you can distribute if you want. 13 was fun. 2, 5, root 6. 1, 5, root 6. All right, 1 over 5 plus root 6. Again, right, denominator, we're going to use this fact multiplied by the conjugate. But this time it's minus. All right, 5 times 5, right, I'm applying this idea. 5 times 5 is 25. Minus, always minus. Root 6 times root 6 is just 6. And then 1 times the numerator. All right, what is this? 25 minus 6, that's 19. Five minus root 6, all divided by 19. Yay, first page. All right, 15, 2, 4. Root 2, 4 minus root 5. Okay, we have square roots everywhere, so I'm going to multiply by the conjugate. Anytime you have a binomial on the bottom with the square root, it's always the conjugate. It's kind of the point of the exercise. Okay, 4 times 4, 16. Minus root 5 times root 5, 5. Yep, root 2 times 4 plus root 5. 16 minus 5 is 11. Do I want to distribute the top? Right, you can't cancel. There's nothing wrong with square roots being in the top. That would be root 10. Yeah, it does me no good, so leave it alone. It's not pretty, but you know, it's the answer. Oh, interesting. I made a mistake. This should have been plus. That should have been plus, which means this would have been negative. Which does what to the denominator? Nothing. Does nothing. What does it do to the numerator? It does absolutely nothing. So we're just off by a minus sign. Haha, funny. Okay. We're halfway through. 16. Okay, multiply by the conjugate. All right, 2 times 2, 4, 10, right? Root 10 times root 10, always separated by a minus. The top, not so much. Okay, so the top we're gonna have to work. So FOIL for sure, double distribution, right? So 2 times 3 is 6. 3 root 10. 2 root 7. Root 70. Okay, then this is going to be 4 minus 10 is 6. So let's just say negative 6. Could we simplify the top? Can we combine like terms? Are there any like terms? Root 10, root 7, that can't combine. Root 70, that doesn't combine with anything. So there it is. That's the answer. Double checking. Negative 10. Yep, looks good. Okay. All right, here the instructions are solve each equation. Number 17, s squared 169. Okay, s squared equals 169. So take a square root, right, to undo the square. Now, anytime you bring a square root to the conversation, right, the square root wasn't there before. I had to introduce the square root to the problem to solve it. So anytime I introduce the square root, you have to put plus or minus. Plus or minus. There's always two answers. Square root of 169. 169 happens to be a perfect square. Right, 13, right, we're saying s is either positive 13 or negative 13. 13 squared, 169. Negative 13 squared, also 169. So plus or minus 13. Number 18, a squared equals 50. All right, square root of both sides. Plus or minus square root of 50. Simplify 50. 25 is a perfect square. 5 times 5. So A is equal to plus or minus 2, 5, because the pair comes out, plus or minus 5 root 2. All right, x squared is equal to 84. Again, square root of both sides. Plus or minus, because I brought the square root to the table. 84. It's not a perfect square. So 2, 42, 2 and 21, 3 and 7. Here's my pair. So x is equal to plus or minus 2 root 3 times 7, 21. Okay, 6z squared equals 150. I always strike my z because my z's and my 2's look alike. Okay, I'm going to divide by 6. $150, is it divisible by 6? I know it's divisible by 3. Well, 6 goes into 15 twice. Right, 12, 3 left over, 30, so 5, 25. Going to square root of both sides. Perfect square. So z is equal to plus or minus 5. I'm gonna run out of time. 21. Okay, negative 3w squared is equal to negative 213. Divide both sides by negative 3. The negatives are the first thing that I see cancel. There's 3 going to 213? Probably. So 3, 4, 5, 6. So quick little trick. If the numbers add up to a multiple of 3, it's divisible by 3. So 3 plus 1 plus 2 is 6. Therefore, 213 is divisible by 3. So 3 goes into 21, 7. 3 goes into 3 once. $71. Square root of both sides, plus or minus the square root of 71. 71 feels like a prime number. Pretty sure it is. We can leave it at that. What else? 22. right, number 22, 4p squared equals 448. I'm gonna divide both sides by 4. So p squared, 4 goes into 4 once, 4 goes into 4 once, 4 goes into 8 twice. So 112. Take over square root. P is equal to plus or minus. All right, let's simplify 112. 2 goes into 11, 5, 6. This is going to be 2, 25, 28. 2 and 14. 2 and 7. So here's a pair. Here's a pair. So P is equal to plus or minus 2 times 2 is going to be 4 root 7. (23) 7 r squared minus 10 25. Okay, a couple more operations that we have to do. All right, so I'm going to add 10 to both sides. That's nice. 25 plus 10 is 35. Divide both sides by 7. 35, 7 goes into 35 5 times. So r squared is equal to 5. Solving for r is equal to plus or minus root 5. Okay, 3x squared minus 8 equals 100. I'm going to add 8. Is divide by 3. Now is 108 divisible by 3? Well, let's check. 8 plus 1 is 9. So 9 is definitely divisible by 3. So 3 goes into 10 3 times. 1 left over, which is 18. So 3 goes into 18 6 times. X squared is equal to 36. Solving for x. X is equal to plus or minus square root of 36. 36 is a perfect square, so it's going to be 6. All right, 5y squared minus 8 equals 2. I'm going to add 8 to both sides. (5y squared equals 10). Divide both sides by 5. 5 goes into 10 twice. So y squared is equal to 2. Solving for y is equal plus or minus root 2. Plus or minus root 2. 26. All right, x squared divided by 25, all minus 6, equals -2. Add 6 to both sides. So x squared over 25 equals -2 plus 6, +4. I want to solve for x squared, so I gotta get rid of the denominator. So I'm gonna multiply both sides by 25. Those are gonna cancel. X squared is equal to 100. Oh, this is nice. 100 is gonna be a perfect square for sure. So solving for x is equal to plus or minus square root of 100 is 10. All right, 27. All right, t squared divided by 20 plus 8 equals 15. Subtract 8 from both sides. (15 minus 8). It's gonna be 7. Again, clearing the fraction, I'm gonna multiply everything by 20, both sides. So t squared is equal to 140. Solving for t. So t equals plus or minus root 140. I'm going to simplify 140. 270, 235, and this is 7 and 5. So only thing that gets to leave is a 2, pair of 2's. So t is equal to plus or minus 2 root 35. It's not bad. All right, number 28. One half x squared minus 8 equals 16. Now I'm going to add 8 to both sides. So 1 half x squared is equal to 24. Multiply both sides by 2. I want to clear the fraction. So x squared is equal to 48. Solve for x. Plus or minus square root of 48. So this is going to be 2 and 24, 2 and 12, 2 and 6, 2, 3. So 1 pair, 2 pairs. So x is equal to plus or minus 2 times 2, which is 4, root 3. All right, 29. All right, 4 times x minus 1 squared equals 8. I want to divide by 4 first. Cancels. X minus 1 squared, 2. All right, I'm squaring a binomial. I'm going to do x times x squared. Actually, I'm not going to do this. I'm not going to do this. It's a completely wrong road. I want to undo the square. I want to undo the square. So I'll take a square root of both sides. So this is x minus 1 plus or minus root 2. X minus 1 plus or minus root 2. All right. I'm going to add 1. So x is equal to 1 plus or minus root 2. So here you can't combine root 2 and 1. They're completely different types of numbers. So 1 plus or minus root 2. Okay. Let's do the last one. Well, number 30 rather. It's not the last one, but number 30. Okay. Is that right? Minus 18. All right, so 7 times x minus 4 squared minus 18 equals 10. I'm going to add 18 to both sides first. So 7 x minus 4 squared equals 28. I'm going to divide both sides by 7. 7's cancel. This is going to be 4. So x minus 4 squared equals 4. I want to get to the x, so I got to take a square root. So x minus 4, square root of 4 is 2. Plus or minus, you can't forget that, plus or minus. And we have, I want to add 4 to both sides. So x is equal to 4 plus or minus 2. So what would that be? 4 plus 2 is 6. 4 minus 2 is 2. So basically 6 or 2. Either one of those answers. All right, you can work through the rest. Word problems. You'll need a calculator for 31 through 34, so good luck with that.